7.5 exponential logarithm equations and inequalities. So you're going to learn how to solve for exponential and logarithm equations. So we have a to the x equals 2 to the x plus 6. What we want to do is we want to get the same base. So a to the x, I can write it as 2 cubed to the x, which equals 2 to the x plus 6. 2 cubed to the x is the same thing as 2 to the 3x equals 2 to the x plus 6. Now that we have the same base, we can say that 3x equals x plus 6. Remember that b to the x equals b to the y, then x equals y, where b cannot equal to 0 and b cannot equal to 1. So then from here, how do we solve for x? Well, I'm going to subtract an x. So then I have 2 to the x equals 6. To solve for x, I divide by 2, divide by 2. So x equals 3. Now I want to check if this is true. So 8 cubed equals 2 to the 3 plus 6. 8 cubed is 512. 2 to the 3 plus 6 is just 2 to the 9th, which is equal to 512. So that it works. Let's do another example. What do we have? 5 to the x minus 2 equals 200. Since 200 is not a power of 5, we need to take the log of both sides. So what I'm going to do, I'm going to write it as log of 5 to the x minus 2 equals log of 200. Since this is an exponent, I can bring it to the front. So now I have x minus 2 times log of 5 equals log of 200. Here I can divide by log of 5, and I can divide by log of 5. So x minus 2 equals log of 200 over log of 5. If you plug this into your calculator, you get a value. Here what we can do is add the 2 to both sides. So when you add log of 200 over log of 5 plus 2, you'll get 5.292 approximately. So that's the value for x. Now you can check. So 5 to the 5.292 minus 2 equals 200. If you plug it into the calculator, you get close to 200. So it's a solution. Now solving for logarithm equations. What do we have? Log base 3 of x minus 5 equals to 2. Since the base of the log is 3, what I'm going to do, I'm going to write it as an exponent. So 3 to the log base 3 of x minus 5 equals what I do to one side, I have to do to the other, 3 squared. Here, since the base is 3 and the base for the log is 3, they cancel. So you have x minus 5 equals 3 squared is 9. So if we solve for x equals 14. And if we check, log base 3 of 14 minus 5 equals 2. This is log base 3 of 9 equals 2. 9, I can write it as log base 3 of 3 squared. You bring the exponent to the front. So 2 times 1 equals 2. So it works. What do we have? Log of 45x minus log of 3 equals 1. I can write this as a quotient. So I'm going to write it as log 45x over 3 equals to 1. 45 over 3 is just 15x. Since it's a common logarithm, which means that it has a base of 10, we can write it as 10 to the log base 10 of 15x equals 10 to the 1. We have the same base, they cancel, so 15x equals 10. If we solve for x, we divide by 15, so x equals 2/3. If you plug it into your calculator, if you plug it back into the logarithm to check, log of 45 times 2/3 minus log of 3 equals 1. This is going to give us log of 30 minus log of 3 equals 1. If we write it as a quotient, it's going to be log of 30 over 3 equals 1. Log of 30 over 3 is just log of 10. And log base 10 of 10 is just 1. So 1 equals 1. Let's do another example. What if we have log base 4 of x squared equals 7? The exponent, we can bring it to the front. So it's 2 log base 4 of x equals 7. To get rid of the 2, we can divide by 2. So now we have log base 4 of x equals 7 over 2. I can write this as an exponent, so it's going to be 4 to the 7 over 2 equals x. The 4, I can write it as 2 squared to the 7 over 2. If I multiply my exponents, I get 2 to the 7th, which equals x. So then x equals to 128. If we check, log base 4 of x, which is 128, squared equals 7. Once again, the exponent, you bring it to the front. 2 log base 4 of 128 equals 7. We divide by 2. So log base 4 of 128 equals 7 over 2. This, we can change it to base 10, and we can write it as log of 128 over log of 4 equals 7 over 2. If you plug this into your calculator, you get 3.5, which is 7 over 2. So it's a solution. If we have log of x plus log of x plus 9 equals 1, we can write it as a product. So it's going to be log of x times x plus 9 equals to 1. If we distribute, we get log of x squared plus 9x equals to 1. What I want to do is write it as an exponent. So I'm going to use 10 to the log. Since you don't see a base, it's base 10 of x squared plus 9x equals 10 to the 1. Since the base are the same, they cancel. So we end up with x squared plus 9x equals 10. If I set this equal to 0, then x squared plus 9x minus 10 equals 0. I can factor this into x plus 10, x minus 1 equals to 0. So then x equals negative 10 and x equals 1. To check, when x equals negative 10, we're going to have log of a negative number. And if you plug it into your calculator, it's going to be undefined because we can't take the log of a negative number. So then this one does not work. What about x equals 1? Log of 1 plus log of 1 plus 9 equals 10. So log of 1 plus log of 10 equals 10. Log base 10 of 1 is just 0, and log base 10 of 10 is 1. So then it equals to 1. 1 equals to 1. It's a solution. Now for solving inequalities. If we have 2 to the x is greater than 4 to the x minus 1, I want to write it as a base of 2. So the 4, I can write it as 2 squared to the x minus 1. What happened to the exponents? You multiply them. So 2 to the x is greater than 2 to the 2x minus 2. Since they're the same base, then I can say that x is greater than 2 to the x minus 2. If I subtract an x and I add a 2, then I have that 2 is greater than x, or x is less than 2. And that's your solution. If you want to check, let's say that x equals to 1, because x has to be less than 2. So 2 to the 1 is greater than 4. 1 minus 1 is going to be 0. 2 is greater than 1. That's true. Let's do one more. What do we have? Log of x minus log of 2 is less than or equal to log of 75. I can write this as a quotient. So it's going to be log of x over 2 is less than or equal to log of 75. Since it's a common logarithm, we will use 10 as the base for both sides. So then I can write it as 10 to the log base 10 of x over 2 is less than 10 to the log base 10 of 75. Since the bases are the same, they cancel, so then we're left with x over 2 is less than or equal to 75. To solve for x, we multiply by 2, multiply by 2. So then x is less than or equal to 150. To check, we can check for when x equals 150. So log of 150 minus log of 2 is less than or equal to log of 75. Or if I write it as a quotient, log of 150 over 2 is less than or equal to log of 75. You get the log of 75 is less than or equal to log of 75, which is true. Now to check for something less than 150, what if x equals 100? Well, log of 100 minus log of 2 is less than or equal to log of 75. We can condense, or we can rewrite it as a quotient. So then we have 100 over 2 is less than or equal to log of 75. Log of 50 is less than log of 75, which is true. Now for Tuesday, work on these problems. For second period on green, work on log base 4 of x plus log base 4 of x plus 3 equals to 1. Third period in red, log base 3 of x plus log base 3 of x plus 2 equals to 1. For fifth period on orange, log base 5 of x plus log base 5 of x plus 4 equals to 1. And for sixth, in yellow, log of 7 to the x plus log of 7 times x plus 6 equal to 1.